All right, well, in this example, we're given a function f with this domain, 2 to infinity, includes 2, going into the range -3 to infinity, given by this function right here. F of x is x squared minus 4x plus 1. We need to show that f is bijective, means 1 to 1 and onto, and then after that, if it's bijective, we know it has an inverse, so we'll find the inverse. Okay, so we need to show bijective. So part of that means we're going to show it's injective, 1 to 1, and then we'll show that it's surjective. So injective, so we want to show it's 1 to 1, so we're going to say, suppose f of A is equal to f of B for A and B in the domain. Right? So suppose f of A is equal to f of B. If it is injective, that means we're going to end up showing that A and B are equal to each other. So, period. Thus, f of A is what? It's a squared minus 4x plus 1 is equal to f of b, b squared minus 4b plus 1. Well, we'll do a little bit of algebra on that, and let's see, we'll get to the point when we set them equal to each other that now I'm going to do a little trick here, I guess. If that's true, then I can say a squared minus 4x plus 4. I'm going to add 3 to both sides. I'm only doing that. It might make it a little bit easier. Didn't have to do that. But only reason I did that is because now that makes it a perfect square. A minus 2 squared equals b minus 2 squared. Now I only have a and b showing up one time on each side. So that means that a minus 2, I'm going to do that square root property thing, although this time I have square roots on both sides. So I have to put a plus or minus on one of the sides. Okay. Well, a little tricky here, but not too bad. This is greater than or equal to 0. Why do we know that? Because we chose A from the domain. A is 2 or bigger. If A is 2 or bigger, this has to be greater than or equal to 0. And likewise, not the whole thing, not the plus or minus, but this also is greater than or equal to 0. So is it possible that if this were positive, the negative sign makes it negative? That's impossible, because this is guaranteed not to be negative. So this tells us that a minus 2 is equal to b minus 2, which implies a equals b. I could have gone here and said that this implies that a minus 2 is equal to the absolute value of b minus 2, and we reach the same result, because the absolute value of b minus 2 is b minus 2, because we know b is from this domain. It's 2 or greater. That is never a negative number inside those absolute values. So we showed that it's injective. Now I guess I have to go over here for the surjective part. So this is like a case 1 and a case 2 maybe. Actually, it goes like this. This is the case one part. Now we're going to do the surjective. Surjective means that every number here will have a number in this set that gets mapped to it. So let me use, we used A and B over here. I'm going to use C. So I'm going to let C be an element of -3 to infinity. Any one of those numbers. We're going to try to find an A in this set. We'll find A in 2 to infinity such that f of A equals C. And then we'll be done. At least we'll be done proving the bijective part. All right, well, if we want f of A equal to C, f of A would be, we're going to give this a shot, f of A would be A squared minus 4A plus 1 equals C. So now I need to solve that for A. And we could do it in various ways. Let me see what the way I did it here. If we want to solve for A, I guess the best way to do it is best way I can think of is using the square root property, completing the square, kind of doing the same thing we did over here. I'm going to say that I'm going to work down here. I'm going to turn that back into I'm going to add 3 to both sides. So A squared minus 4A plus 4, just like we did over there, is equal to C plus 3. Why did I get that? I did plus 3 there, and I did plus 3 there. Now, it makes it kind of easy. That's A minus 2 squared equals C plus 3. We do the square root property again to get A minus 2 on the left equals plus or minus C plus 3 under the radical. So A is equal to 2 plus or minus C plus 3. So what we would do is simply show that, well, first let's convince ourselves that this number is a number in this set. What is the biggest a radical can be? I'm sorry, the smallest a radical can be. A radical means take the positive square root of what's underneath. So what's underneath is a 0 or greater, which makes sense because C came from this set. C could be -3 to infinity. So even if you put a -3 in there, you get a 0 underneath the radical. You'll never get a negative number. And radical is always a non-negative number. So this A is going to be 2 or greater. So that works. And we can show now that f of, let's see, A is f of 2 because A is 2 to infinity, we can remove this negative sign. So it's really, I'm going to write that down. A is equal to 2 plus radical C plus 3. That's the value of A, that if we put it into the function, we'll get C out. We can verify that. I'm running out of room. I'll leave this for you. I'll say, can verify that f of 2 plus radical c plus 3 is equal to c. So you'd have to take this right here. You would square it. Where's the function? There. Square it, subtract 4 times it, and add 1, and you would get c. And since I've kind of run out of room, finding the inverse, we've actually done all the work to find the inverse. All of the 4 steps are in there. F inverse of x is equal to 2 plus x plus 3. We already went through the recipe. This is basically what it is. We essentially, we didn't do the interchange, but we set a squared minus 4a plus 1, f of a, equal to c, and then we solved for a. So that's the inverse function. And you could verify, this, and then also that f inverse of f of x is equal to x, or f of f inverse of x is equal to x. Those would both be true as well. So that one took a little bit of work, mostly because the radical made it tough, the algebra, but we proved that it was injective and surjective, so it's bijective, and in all this work, we kind of did the 4 steps necessary. We found out that this is the inverse function of f. And again, let's see. Yeah, not quite as easy to tell by looking at them. There is a square root in that one, and there is an x squared in that one, but other than that, the numbers don't really match up too well. But good problem.